Hello and welcome to Lux's webinar, Sensing for Insight, Getting the Most Out of Commercially Available Sensors. My name is Andrew Stockwell. I lead Lux's global research, consulting, product, and marketing teams, and I'll be your host today. Our speaker today is Tom Dawidzek, analyst extraordinaire. Tom leads Lux's Sensors Intelligence Insights at Lux. If you have any questions for Tom during the course of the webinar, please enter them into the Q&A box. If you have any questions about Lux, or any questions as follow-up, please email them to questions@luxresearchinc.com and we will follow up with you directly. Before we do get started, a few words about the challenges we are seeing in digital today and how Lux is helping companies like yours drive innovation and growth. So based on what we see in the marketplace, the digital competitive landscapes and ecosystems are changing incredibly quickly, risking market share and profit margin for our clients. Certainly, rapid development and proliferation of new devices puts pressure on suppliers to stay ahead of trends in order to meet tomorrow's demands. Traditional markets and operations are becoming digitized, but each comes with unique challenges and value propositions. Innovations from 3D printing to machine vision are changing the nature of manufacturing and business process. And digitization finally is disrupting current business models and the way customers use and pay for products. So, as a company, how do you find and foster new growth? Well, although innovation challenges remain largely the same, approaches to spotting transformational technologies rely still too heavily on traditional foresight or automated data. Companies today need to supercharge their innovation with the right data and insights to get at the what, who, and when of technology innovation. Lux steps in and helps our clients by providing expert curation of data developed via advanced analytics, plus domain knowledge from technology experts such as Tom to sort the significant from the spurious, and insight on what it means and what to do about it. We are, quite frankly, the leading provider of tech-enabled research and advisory solutions, helping clients drive growth through technology innovation. Now, as a demonstration of our approach, I want to pass things off to Tom, who is going to take us through a brief discussion on the state of sensors and why sensor fusion is important now, some recommendations for how to strategically implement and obtain more value out of AI-enhanced sensors, and then he will conclude with some predictions for the outlook for sensors. Tom, over to you.
Thanks, Andrew. In this webinar, I was looking to speak a little bit about how commoditized sensors are being implemented with AI and machine learning techniques, and you can actually now start to extract more value out of them than their original design intent. So to get it started, if you imagine now thinking of just a regular piece of cardboard, and how can you change that basic piece of cardboard into hundreds of dollars of value? This may seem like a hypothetical question, but it's actually something that's already being done now, and we're seeing it even with the Google Cardboard. So as an example, you can use the Google Cardboard in a smartphone, use that to completely replace an Oculus Go or other types of VR headsets. So now there's actually no sensor within the cardboard itself, and you're only using the smartphone sensors. This allows you to reduce the cost of the VR headset from $200 now to just $15. In this case, we can actually start to extract more value just by using smartphone sensors. So you can imagine a regular consumer being able to just use their basic smartphone sensors and have a fully immersive VR environment without having to have any specialized hardware. But how is this done? The three sensors that are going to be used are actually in one basic sensor called a 9-axis accelerometer. This is also referred to as an inertial measurement unit, but because these three sensors are so commonly used together, we just call this one sensor now, an IMU, or a 9-axis accelerometer, but it's actually three distinct different types of sensors. It's an accelerometer, which is going to look at the linear motion. It's a gyroscope, which will look at yaw, pitch, and in rotational motion, and a magnetometer, which is going to look at slight changes in the magnetic field based on the position. So by using these three individual sensors in the three axes, you can actually get a better position or better location sense than just one of these sensors alone would give. So as an example, a gyroscope would have continuous bias, but by combining the sensor data from the accelerometer and the magnetometer, we can actually reduce the bias of the gyroscope and make it a better sensor. So again, the combination of these three sensor data streams actually provides more accurate data than just the individual sensor. This is one example, but how is sensor fusion important for you in your applications? So data is a critical differentiator in many of these business issues. And what we're really starting to see is anything from operational efficiency to consumer engagement to new product development, all are driven by data nowadays. And if you're not doing this, your competitors definitely are doing this. So how can you start to use data as your critical differentiator for your applications or your processes? So if we now start to dig into just more specific data, as an example, enterprises, in the case, let's say, of a smart factory, can generate up to 1 petabyte of sensor data every day. This is an extreme amount of data for a very kind of large factory that would be in use, but what are you going to do with all this data that you're collecting from your smart factory? Also, if you think of a plane, one plane during flight can generate up to 2 terabytes of data in just in a regular flight. All of this data is being collected, but not all of it is being used. So some of this is actually being wasted. So you're sensing for things, you're sensing for either location or other parameters that you're not actually using, and you're sensing too often. You may be hoping to someday find value in this, but can you actually extract value from it today with your current capabilities? So really, if we look at a lot of the data that's being used, less than 1% of the data is actually being used many times. So you're really not sensing for what you need, you're sensing too often, and you're hoping to someday find value in this data that you're actually collecting. But there are effective tools that you can start to use and implement in your processes or in your products that can dramatically improve your efficiency and actually make it so you're sensing for the proper things within the proper context. And so these tools exist today and are going to continue to get better as we develop these processes and techniques. And what's one driver of that? And so one driver is looking at just the AI investment the funding investment in hardware and sensors for AI. In this graph that I've shown, there's been a 92% CAGR since 2013. This is now up to about $10 billion in 2018 of funding going into the hardware and the sensors themselves. So this is generally going to indicate that we're going to see better improvements in sensor capabilities and edge processing for the sensor data itself. So this is only going to further drive innovation and improve the capabilities of these basic sensors. So AI sensor combinations are going to improve and continue to improve in the future. So in this webinar, I wanted to talk about how this is being implemented currently in the real world, and then go into a little bit about how you can put AI-enabled sensors to use in your applications, and lastly, give you an outlook for what to expect in the future. So diving a little bit deeper into some implementations in the real world for examples, if we take two very, very common commoditized sensors, so the IMU, that's the accelerometer, the 9-axis accelerometer that I talked about previously in the Google Cardboard example, and we take another very common commercialized sensor, which is a microphone. These are two very, very common ubiquitous types of sensors, but now we look to actually fuse that data together. So we take the data from the IMU and we use the data from the microphone and contextualize both of them. Overlaying some machine learning algorithms, we can actually do this processing now either in the edge or in the cloud, but this gives us a new AI-enhanced sensor. So now we're not just sensing for motion, what the IMU would sense for, and we're not just sensing for sound, what the microphone would sense for. We're able to combine these two sensors and get what we'll call an AI sensor. This allows better capabilities and better context. So AI can combine, using AI and combining these two data streams together, we get a new sensor that has better capabilities than its two component sensors by themselves. If we look to see how some developers are actually looking to implement just a microphone and just an IMU combination, this is used in a lot of applications. If we first just look at an industrial application, there are a lot of different uses from livestock health. So this would be looking at a cow's health and looking at the noise of the rumination sounds and the motion of movement. This would give you greater insight into the cattle's health. But this isn't just livestock health. It could be used for worker safety and predictive maintenance. In these applications, these are not the only developers looking at these uses, but they're just to give you an example of two sensor combinations, the microphone and IMU, and how they're being used currently in these AI-enhanced sensors. But it's not just industrial. It's also happening in consumer applications. We can now start to think of smart home appliances. So whether it's a device that's going to be like an Alexa, or if it's going to be a security device that's looking for windows and break-ins, these two sensor combinations do allow much better capabilities than just the single sensor alone. And the other vertical that I did want to talk about is health. So this is not by any means an exhaustive list of different verticals or different use cases, but it's just to illustrate that these two sensors, the microphone and the IMU, can be combined and actually create a new AI enhanced sensor for all of these different applications. If we get a little bit more in depth into the healthcare applications, the example of the Healthcare Originals Atom device, here we say it's using for breathing, but it's looking at asthma and being able to prevent an asthma attack in an individual just by looking for respiration sounds and chest movements. So again, these are looking for a wide range of applications using these same two sensors. If we dive a little bit deeper though into this health application and we choose sleep, I'm choosing this example because everybody that's listening to this also sleeps, and you can start to think of what are the combinations of factors in your sleep that you can sense for. So this toolkit, if we take an example of sleep, is not just motion and microphones, but there's other sensors that can be combined as well. Now, if we look at motion or position, that can be done with the IMU, but noise is a microphone. We can also now look, though, at skin temperature. This changes as you're sleeping. Pressure could be done via a mat or something where you're able to look at how the position of your sleeping is influencing your sleep. Heart rate can be done with a normal PPG-based optical sensor, and brain activity can be done with a EEG-based sensor to look at your brain waves. All of these could be combined in some fashion to create new AI-enhanced sensors. There's a host of different ways of doing this, and it can be quite confusing to know which one is going to be the best for your application in your use case. So you can have anything from the Aura ring, which would be a wearable ring that you just place. In that case, it's using a heart rate sensor, the IMU, and a temperature sensor. But you could also have something like your basic Fitbit, Apple Watch, or other type of fitness tracker that's just using an IMU and PPG sensor. There's a wide range of these applications, and if we get into one even more specific, the Better patch is actually a forehead-worn patch that uses an IMU and heart rate sensor. So how do you know which one's best for your applications and what you're looking for? This is where we actually want to go through and look at what are the factors that are actually influencing your sleep and your sleep quality. So one of the first factors that are going to influence your sleep quality is the time of sleep. But in all of these applications, we can actually measure time pretty readily. So the other three factors that we actually want to look at are position. So this will be how you're oriented as you're sleeping, the stage of sleep that you're in, and whether or not you have sleep apnea. If we go back now and compare our toolkit to these various types of factors, each factor will be able to be sensed by specific sensors. So position can be monitored by an IMU for motion and position or pressure sensors. The stage of sleep can be monitored by almost any sensor in this list except for the microphone for noise. And sleep apnea can be monitored by the motion, noise, or pressure. So again, there's a host of different ways of sensing for these factors, and you're going to have to start to find out which works for you. It can be quite confusing, and if we just look at the individual sensors that are sensing for this, if you only look at accuracy and price, you maybe think you have a good idea of the sensor to use for your application. However, sometimes this can be misleading. So we really want to look at not just accuracy and price, but we also want to look at the ease of deployment, the power consumption by the individual sensor, and the processing requirements for this sensor. So if we combine all of these together, position seems to be almost any type of sensor can be appropriate. That would be the top row. But then for stage of sleep, we actually see that pressure generally seems to be one of the preferred sensors for this. And for sleep apnea detection, it seems like the microphone should be the preferred sensor for this application. Circling back now to this original list of developers, who's using the microphone pressure sensing and an IMU, let's say, to do this? Well, really, it's only now the Beddit device by Apple. Pause. The next slide has a whole bunch of W's in it, so I'm going to have to do take two on the next slide. I didn't notice that, and so there was.
Oh yeah.
So somebody was like, there was a bunch of W's on the. Hopefully that's the only one.
Do you want to just check the rest of them while we have them?
Yeah. Sorry, but I didn't notice that
It's
when
okay.
I went through and did. Yeah, they all seem good. Okay. Yeah, I don't know if there was. It seemed like a key got stuck in when somebody was on that. So now we were on this one. I'll go back to. I gotta move this. Yeah.
Yeah. So with this, if you want to just hit the arrow, the orange arrow. Yep.
Oh, that's better. Yeah.
Slide it
I was looking at the volume to see if I was then like speaking loud enough.
Yeah. Yeah, I would because you're a pretty light speaker, I would always encourage you to speak.
Yes.
louder.
You're
Talk
coming
louder.
through just fine. So
Okay.
exactly how you're doing is great.
So if you can just start from the top, pause, start from the top,
Okay.
and then keep going. Be great.
Okay. Take two. So what are the ways that these are being implemented in a device now? And really, it's only the Beddit device by Apple which offers all three of these sensors in combination. So the IMU, a pressure sensor, and a microphone. So the Beddit device is actually a bed pad that's going to be a strip that runs over the bed and is going to be hardwired into the outlet. So the ease of deployment here we call is the bed pad, but this is essentially you can think of as a form factor or a device form factor. So now let's compare the Beddit device to the others in this application. In terms of accuracy, these are both on par with one another. The US FDA has said that really for any true clinical quality sleep monitoring, you'd want to do it through a certified clinician. So in this case, these are all going to just be for general baseline measurements. From a price perspective, there are far more expensive devices, let's say the Sleep Shepherd device. So price will give the win to the Beddit on the average costs. And then when it comes to ease of deployment and power, the Beddit device wins. Here, it's very easy to just lay this strip directly across the bed. You don't need to worry about recharging and having a wearable. And the power consumption is quite good. Lastly, the processing, these are about on par with one another. So overall, the Beddit device seems like the preferred solution. So this is just one example of how you can combine two sensors or more and create a new AI-enhanced sensor. So while that's one, I want to now help you determine how you can start to put AI-enabled sensors to use in your applications. So if we dig a little bit deeper, we first want to see if you're looking at your sensors in your applications. Do you predominantly use commoditized sensors, or are you using very specialized sensors for your application? Very specialized sensors you can think of as more chemical sensors or very specific sensors for a process or a product. Commoditized sensors you can think of more as an inertial measurement unit, microphone, or even camera. The next step you're going to want to do is minimize the number of specialized sensors that you're using. Ideally, if you can start to replace a very specialized sensor that can be far more costly with a commoditized off-the-shelf sensor, this not only reduces the product costs, but you can now start to combine these commoditized sensors together. Lastly, one step that you should take is to start to look across different industries and see the other implementations that are being used with these sensors across different industry verticals. So if we take the example of a consumer device, you can now imagine the consumer device in applications for, let's say, a Alexa could be very readily implemented in other uses and applications, not just consumer, but health or industrial, let's say. So there are a lot of different use cases that you can now start to look at across different verticals, and this is where Lux comes in and starts to look at these different verticals. So if we get a little bit more into the outlook and what to expect, first, AI is going to enhance basic sensors, and then these basic sensors will start to replace more specialized functional sensors. So expect in the next few years that AI is going to first enhance these commoditized sensors, then it's going to go in and replace specific industry sensors within different verticals. So these are primarily going to be the optical sensors, maybe some acoustic like microphone sensors, and mechanical sensors like an IMU or a strain gauge. Next, sensor fusion is going to become more common. I think that you can see from this presentation here today that this is happening, and it's happening across a host of verticals. But these multiple sensor streams will come together and help decrease the noise that you'll see in individual sensor readings, and it's going to help the probabilistic nature of these machine learning algorithms to only improve the AI-derived sensor capabilities. Next, the development cycles, regulations, or RI is ultimately really going to be what determines your adoption. So you can imagine now a medical application, because of the regulations that are involved, may be a little bit slower to implement, but consumer applications may be faster because of their development cycles. So while consumer may be faster, other applications such as industrial or medical can start to look to consumer as the first wave of implementation. Lastly, competitive barriers are going to determine who wins in this space. So as a company, are there specific data sets that you have that are proprietary that no one else has access to? Can you use these data sets to better refine your machine learning algorithms and better hone in on your applications? These are going to be what help determine who wins in this space, and can you start to look at how you can use your proprietary data in your applications. So with that, I wanted to thank you for listening to this webinar and open it up for some questions.
Thanks very much, Tom. A tremendous presentation, incredibly informative. Let's now, in fact, get through some questions here from the audience that have come through during the course of the webinar. A reminder that if you do have questions, please enter them into the Q&A box on your screen. So, Tom, let's take one of these first ones that I saw as you were speaking. So this first question is around the prices of sensors, and the person asking says, well, the prices of sensors are decreasing. How affordable are the analytics and edge processing when building business-specific applications?
So that's a good question. And we didn't dive a lot into that in our talk today. And we actually have a very specific group within Lux that actually goes through and is devoted to AI and edge processing. And they'll help clients kind of go through and assess these questions within their industry and vertical. But each vertical is going to have its own use case and applications. So I won't get into each one of these specific requirements. But if you really think of either using a light version of traditional machine learning algorithms, or if you start to look into new kind of processors like a GPU in sensors, really the light algorithms are going to be the cheaper option. So they're going to be a little bit cheaper, but the capabilities are lower. So you're going to get what you pay for. If you start to look at the GPUs, they can actually do a lot of computational complexity, but they're going to cost more expensive. They're going to be more expensive to implement. So an example of some of the innovation in the space, just recently, AI Storm raised $13 million to have some new competing chip that kind of competes with a GPU and lowers the cost for IoT devices. So this would be one use case and one implementation, and you can see innovation in this space. But really, if you're looking at implementing this, let's say in a manufacturing environment, your infrastructure is really going to be the determinant of what's going to be easiest to implement. So, there could be technologies like 5G or other high latency or limited bandwidth things that could constrain it. But really, I would say your infrastructure and how you're implementing it is going to be what determines your overall cost.
Okay, great. Thanks, Tom. Another couple of questions that came in that have a similar flavor to each other is asking about industrial applications. So I think the question is, how could these sensors that you described in your presentation be used in industrial applications? Do you have any examples of that?
Yeah. So, and one example, let's say, is we had that slideshow of towards the beginning where we talk about a few of them. And so predictive maintenance is probably the hottest one for a lot of digital transformation in these physical industries. And here there's a different toolkit. So while we talked about the sensor toolkit for sleep monitoring, the toolkit for, let's say, predictive maintenance is actually quite different. So while you may still use an IMU and a microphone, you're going to have a different type of sensor that you're going to start combining these individual sensors with. So here we've done a lot of research on predictive maintenance and spoken with a lot of companies in this space to get a better sense of these individual solutions. And they're not all created equal. So in this case, you're going to actually want to look at the individual sensor that each device is using and really look at the machine condition. So if we consider the ability to monitor for machine condition, sensors, let's say like a thermocouple, may be a little bit slower. And if we conversely look at something like power consumption, this can be a better indicator of this device. So within our database, we'll have different developers that look at these individual sensor combinations, and we can kind of refine your solution based on this database.
Okay, great. We have time for one last question here, Tom, from the webinar. So a question in here about what do you think are the most common, or what do you predict are the most common sensors that will be used in sensor fusion?
That's another good one. So, in this slide that I showed at the beginning, we talked a little bit about a microphone and IMU. These are going to be pretty common, but I think the biggest or most commonly used one is going to be a camera. And so we actually recently wrote a report about AI enhancing sensor capabilities. And there we went through and dove in with our analytics and kind of looked at the patent publications in this space and found that the greatest number of patents in this space are actually with cameras. So machine vision applications are going to be the biggest driver of this. And then it's kind of followed up by microphones and IMUs as the second and third application. So this is just driven by the data that we collected with our patent searches and some funding data. So those are probably the three biggest applications in this.
Okay, great. That's a great start. And unfortunately, that is all the time that we have. As a reminder, if you have any questions that we didn't get to during the course of this webinar, or you come up with questions after the webinar about the webinar, Tom's presentation, or any content or about Lux, please do email us directly at questions@luxresearchinc.com, and someone will be sure to get back to you. You can also, of course, follow us on LinkedIn and Twitter, or our blog at luxresearchinc.com for ongoing information, data, and insights. Thank you all for your attention, and thanks again to our presenter, Tom. Have a great day, everyone.